Hey everybody. I'm sure it's been quite a while since you thought about integration or did any integration practice. So let's do these warm-up exercises, partly as a little review, but partly because you'll need to understand these particular integrals for the next video. If you didn't try these yet, I'd really encourage you to stop the video and work them on your own. Go find your old notes or the old part of the textbook that you used to use when you were learning about integration and do a little reviewing if you can. Anyway, we want to find the integral from 0 to 1 of 6e to the minus 6y dy. Now, we have a basic integration formula that says the antiderivative of e to the u du will be e to the u. And then if it's a indefinite integral, you have to put a plus c on. Now, if we had e to a letter times d and the letter, we could use this formula. But we don't have something quite that simple. We have something a little more complicated. So the trick for dealing with this was to take that thing that you wish was a single letter. So the thing I wish was just a plain old letter is the exponent on the u. And I'm going to clean that up and turn it into a letter by letting u be that whole thing in the exponent. Then we carry through with what else that says about u, and it says du would be minus 6 dy. Now I'm going to want to turn all the y's in my integral into u's, so I need to know what to put in for dy. Let's divide both sides of this guy by negative 6. And that way I can see that negative 1/6 du is what's going to go in for dy. Oh, I didn't realize that was going to be quite so fancy. Okay, back to our integral. I've got the integral, I've got the 6, I've got e to the minus 6y, but minus 6y now has the name u. And I also need to put something in for dy that has u's instead of y's in it, and we just determined that what's going to go in for dy is minus 1/6 du. Now, I can't just ignore the limits of integration. You might recall there's a way of turning them into u's. I'm going to just leave them as y values, but I have to label them as y values, because if you don't, it's assumed to mean that those numbers apply to the whatever variable is inside your integral. And since we've changed to a different variable, and these no longer apply to that variable, we have to label them with the variable that really does apply to them. Let's clean up our integrand. I can cancel the 6's, and I can also bring that minus sign out front. Remember, you can always bring constant coefficients out front. So now I have the integral from 0 to 1 of these y values. And inside the integrand, all I have is, oh, and there's a minus out front. And inside the integrand, all I have is e to the u du. Now we can use our formula. The antiderivative for e to the u is just e to the u. And I do have that minus out front that I need to carry through. I don't need the plus c because we have numbers to plug in. You only do the plus c when there's no numbers to plug in. Now those are y values, so I need to get the y's back into my expression, but that's very easy to do because u is just the name we gave to minus 6y. So if I change the u back to minus 6y, now my 0 and 1's apply perfectly, and so first I plug in the 1 Then I subtract what I get plugging in the 0. So it looks like we wind up with minus e to the minus 6 plus 1. The next integral is almost exactly the same as the one we just did, except that instead of 6 in there, we have the letter a, where a is a constant. And I wanted to do it in this format because what we're going to be doing in this section is going to involve having a letter that we have to treat as a constant. Like we did with partial derivatives. This is like the reverse thing of partial derivatives. So let's run through this. I'm going to do the same u substitution where I let u be the thing in the parentheses, so minus ay. Then carrying that through, that tells me that du would be minus a dy. So I'm going to be putting in minus 1 over a du for the dy. This gives me then integral y is going from 0 to 1. I've got a, I've got e to the u because minus ay has the new name u, and dy is turning into minus 1 over a du. Once again, the constants cancel and the minus sign can come out front. At this point then we have definite integral from 0 to 1 of just e to the u du, except again I forgot that minus sign out front. Antiderivative of e to the u du is just e to the u, and I've got to keep the minus sign from out front. We're evaluating that from y equals 0 to y equals 1. So I need to get those y's back into the expression. U was just our name for minus ay. So now I'm ready to plug the y values in. Plugging in the 1, I get minus e to the minus a times 1, then minus what I get plugging in the 0, which is minus e to the minus a times 0. So we get minus e to the minus a plus 1. So same exact answer as last time, it's just that there's an a instead of a 6.